So the last, but not the least, we have Sulev coming up from University of Tartu and the Software Competence Center to talk about how can still be health data, the most sensitive one, be made available. All right.
My name is Sulev Reisberg, and it's glad to be here and talk about my favorite topic, which is how it's look like to work with digital health data. But first, a couple of words about myself. I've been working for more than 10 years in health informatics field. By now, at Curatech, we built the software for national health registries. At Stack, I'm involved in doing some big data analytics, and in IMIF project, which is a joint project between the European Union and the pharma industry, I represent the database of Estonian Genome Center. So I've been in different roles when working with the data. And I tried to share my experience how these roles could work well together. There's the data, and there's the public benefit. We know that there's a link between them. However, the link contains several steps. First, the data has to be extracted and released from the original database, which could be a remarkable headache for the database manager or, let's say, data custodian. In order to start analyzing the data, the cleaning part and data pre-processing part has to be done, which, again, could be a very difficult task. And the analysis results, and often the tools that visualize the analysis results, can then be used by the decision makers and in the end lead to the public benefit. Let's talk about this releasing part first. This is the view of data custodian. The biggest problem for the data custodian is that the data has grown really huge. And your in-house Excel skills are not enough to analyze it. You need a different competence. And you may be forced to give the data to someone who can analyze it. And due to the lost overview of the data, you're also concerned about giving the data out. How can I release the data if I don't know what's in there? And for the research, you have to pick out all personal data like names, personal IDs, addresses, mobile phone numbers. And with very many databases, especially with the medical ones, this kind of personal information is mixed together with other data. And picking out this personal data is, without affecting other data is not a trivial task at all. And that brings us to the second problem, which is it really needs an effort to release the data. And often you may not have tools or lack of procedures to do that. That's why we built the tool, what we called anonymizer. It gets some text as an input, very typical to the medical documents, and it automatically finds parts in the text that include some personal data. And it just replaces this kind of data with X's. And it really helps the data custodians to get the anonymized data for the release. And as these tools can be solely run on the data custodian side, then the personalized data actually never leaves the original database site. Now about pre-processing the data. When the data reaches finally the researcher, then the researcher soon discovers that the data is messy. And what I mean by that, it basically means that the data is not machine readable. And it either, the information is packed into complex PDF format or complex XML files or has encoding problems or the values are given in the free text or something like that. It needs a lot of pre-processing work to actually get the valuable data. Some examples. Here you can see the real-life examples from the medical documents in Estonian, how the heart rate is given in the documents. As you can see, the patterns vary a lot, and in order to get the numerical value out of this, you need to do some regular extraction, which is a difficult task. Another task is to detect the meaning of abbreviations. The very same abbreviation can mean different things in every language, but also in Estonian. For instance, the single letter P can mean the right one, the day, parietal, pupil. And you have to use some context-based machine learning algorithm to actually estimate the meaning of the abbreviation. And why it's important? While in normal written language, the amount of abbreviations is less than 2%, then in medical texts, this number is 13, which means that every 7th word is the abbreviation, and you have to deal with that. Synonyms. The very same things can be written by using different words. If you're searching for a particular event or term, then you have no idea what are all the synonyms for it or alternative phrasings. And that's where we can use the tool called Texta. For example, let's search for some painkillers, paracetamol and ibuprofen. You insert those two words, and then the system scans through all medical documents and finds the words that are used in the very similar context. For example, a lot of typos and syntactical errors come up, but also the synonyms. And you can add those also to the original search, and in the end, find more documents. And if you are doing a research, then you really don't want to miss some particular event due to the typos or errors in the writings. Having done all this, you can start doing your analysis, which usually starts with getting the overview of the data. In this example, we made an interactive tool to visualize the budget of Estonian Health Insurance Fund. It not only shows the planned budget, but also the actual expenses so far. The red bubbles here indicate the health services where expenses have been larger than the planned budget. This kind of overview really helps to get the how to say, good intuition what's in the data, and help decision makers not only to plan but also to track the budget. And of course the same method can be applied to some other data also. For example, to find out what are the most expensive diseases, for example. We can dive more into the data and look for the patterns. For instance, in this example, we analyzed how the patient travels between Estonian counties. And this analysis is based on the insurance bills. For instance, you can have a cataract surgery, which is certain eye surgery, in 4 counties in Estonia. You cannot have it in Lääne-Virumaa, and that's why the people there are traveling mainly into the capital city, Tallinn. What is interesting, that in the second place is not the neighboring county in the east, but Tartu instead, which is located much farther away. And why people are not going to Pärnu? Is there maybe a quality problem, or language barrier, or probably they just miss the connecting public transportation? Such patterns are hard to read from the tables, and the decision makers don't want to read the tables. This kind of interactive visualization can really empower them to explore the data, and that's what they're usually waiting for. If you're dealing with medical data, then sooner or later you're reaching to the point where you want to get an overview, what has happened to the particular patient. The overview should be at the same time simple, but also comprehensive, to exhaustive, I mean, contain everything important. For example, what have been his diagnoses grouped by the body region? Or what are the numerical values that you extracted from the text, put on the graph? And also, what is the value compared to the reference range? Here the dashed lines indicate the reference range. For instance, this particular patient has a code which is connected to the diabetes, and we can see that his blood pressure is slightly over the norm. However, the blood glucose and the cholesterol level is perfectly in the allowed range. We can build such overviews on the medical records already, and also for the medical insurance bills. And we have set up the system to also collect the self-reported data from our smartwatches and mobile phones. And this kind of information could also be added to the patient summary screen. Together with the upcoming collaboration with the University of Edinburgh, we're also adding the 4th component to the puzzle, I mean the genetic data. And putting together different pieces of the data about the same patient can really lead to better decisions, better treatment, and towards very personalized medicine. Okay, I'm now reaching to the end of my talk. What can I suggest? If you are a policymaker, then make sure that the research is not forgotten out from the overall or general data handling process. You should put your effort into building a secure technological and also legislative environment for releasing the data for the research and development. If you're a data custodian, then make the collaboration with the researchers and the universities the standard way how your organization works. And if you're a researcher, then go and help the data custodians. And also let them reuse the outcomes of your project. And if this all gets working, then the magic will happen. I'd like to thank all my colleagues and the partners who helped me a lot with this presentation and built all these tools. And thank you for listening.
All right, questions to Sulev? Perhaps the first one I would ask is that, so obviously you did lots of work exactly from the health field, but has any other sector, any other policy area approached you, or let's say if not, then whom would you wish to come to the door? Because I think many of these things can be applied in various areas.
Yeah, actually, we soon discovered that the very same methods can also be applied to other types of data also. Mm-hmm. And what we have tried, for instance, we could analyze the shopping baskets, shopping carts. What kind of people are there? What are the typical clusters of the customers, what they buy? And also, what was very interesting project was the online news portals are aware of the comments to the articles. And we made a prototype for detecting automatically the racist comments.
Okay.
So they could easily find them and decide what to do with them. So
all right.
The same methods can be applied to different sources.
But no other public agencies yet, no other public sector policy areas yet?
I have no experience so far, but I'm pretty sure that actually the typical work is still the same. Mm-hmm. Please release data, do some pre-processing, then you can analyze.
Okay.
And it seems to me from this conference that the visualization is the key part here. This should be the result of the big data analytics.
Well, like I said, I mean, you have to make it understandable. All right, thank you.
Thanks.